In this video we have the integral of x minus 1 over the square root of x squared minus 2x. The first thing you need to do, of course, is determine what method will apply to evaluating this integral. Got a rack on the denominator. You might consider completing the square of this radicand here and using the formula for the inverse trig function, or one of the inverse trig functions. If you have a rational expression, of course, you might consider partial fractions and so forth. But the first thing I like to look at is there a substitution, a U-substitution I can use to make this easier to evaluate. As always, there could be more than one way, in some cases 2 or 3, depending on the integrand. But I look at this right here, and I take the derivative of this, and I get 2x minus 2. And then I see that if I take out a factor of 2 here, I get an x minus 1. And I got the x minus 1. Also have the 2. But remember, the constant you can deal with, because you can always factor out the constant from the integrand and put it outside the integral. So that tells me that a U-substitution is going to work here. So I say let u equal to x squared minus 2x. Then du would be the derivative of that is 2x minus 2. And I can factor out a 2 from that. And of course I also have the dx here. So I come up with 2 times x minus 1 and then the dx. And notice I have x minus 1 dx in the numerator. So dividing through by 2, on the left side I'll have du over 2. On the right side the 2's going to cancel, and I'm going to have x minus 1 dx. So the objective here then is to transform this integral into one involving the variable u instead of x, and then doing the integration using the basic formulas that we can use. And then at the end, once you've done the integration in terms of u, you go back to the original variable. So for this one then, this becomes the integral of, and again, the x minus 1 dx right here is replaced by du. So I'll put the du there. Instead of putting over 2 here, that's just multiplied by 1/2, so I can factor out a 1/2 here. And then the denominator, x squared minus 2x, that's your u. So that's the square root of u. I'm going to write that e to the 1/2. And this then becomes 1/2. And then to make the integration easier here, just take this to the top. Changes the sign of the exponent. So instead of positive 1/2, a negative 1/2 du. We have a basic integral to evaluate. Add 1 to the exponent here, gives me a 1/2. And then divide the coefficient by 1/2. Of course, the coefficient is 1/2, so that's going to cancel out. And then I'm going to have the constant of integration. And then finally, once you've completed the integration, go back to the original variable. You're going to give the answer in terms of whatever the original variable was. In this case, it's x. So u is equal to x squared minus 2x. And I could write that as x squared minus 2x to the 1/2, but since the original was given with a radical expression, I'll write it this way, plus the constant of integration. Now if you have time, you can always check your answer by computing the derivative of this result, and it should give you the integrand over here. So the answer to this one is the square root of x squared minus 2x plus the constant of integration. Thanks for watching. We'll see you next time.